Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of -418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. your lungs would collapse and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
So, astronauts always have a lot of work to do. They deal with breakdowns on the ship, go into outer space to repair something, conduct experiments, keep daily records, report about everything to the center of the Earth, and sometimes meet unknown mysterious things from outer space. Let's see which ones. So, you're alone in a small spaceship. You have our big planet on one side and the boundless black space on the other. You're checking instruments, doing some astronaut things, when you hear a strange knock. Someone or something is knocking on your ship. You realize that this is impossible, but then the knocking repeats. You look out of the porthole window, but don't see anyone. Then you report the incident to the dispatcher on the ground. No one knows what it could be. You've been training your stress tolerance and psyche for many years, but now you're a little nervous. Astronaut Yang Liwei first heard a mysterious knocking sound in 2003 when he was inside a small spacecraft as part of the first Chinese space mission. Yang said the sound was like hitting an iron bucket with a wooden hammer. He also noticed that the knock came neither from the outside of the ship nor from the inside. He couldn't determine its source. When Yang returned to Earth, he tried to reproduce the knock so that experts could discover its nature. But no one managed to find out what it was. A similar story repeated itself with other Chinese astronauts in 2005 and 2008. Young's colleagues suggested that the ship could make the sound due to the hull's expansion or compression. The temperature inside the ship was very different from the temperature in outer space, and this could cause the metal hull to make a sound similar to a knock. Hey, don't knock it. Another mysterious sound was heard by NASA astronauts on Apollo 10 while orbiting the Moon. It was a strange whistle of unknown origin. One of the astronauts described it as cosmic music. The information about this incident was classified for a long time, but recently NASA has explained the mystery. The whistling sound was just some radio interference. But it doesn't mean there are no creepy sounds in space. NASA has launched many research probes into the boundless depths of space. One probe recorded the sounds of Jupiter, another the sounds of Saturn. The third probe recorded dust particles and small rocks crashing into the ship. Technically, these are not sounds because sound waves cannot exist in space. The ships recorded radio emissions from various objects, and then scientists transformed these waves into sounds. And the coolest thing is that you can find all this on the internet. There were many rumors and legends about Neil Armstrong and his landing on the Moon. One of the most popular myths tells how the astronaut saw strange spaceships on the Moon. The astronaut never commented on this case, and his testimony and the data he gave to the communication center on Earth was classified. But, according to the legend, Armstrong said creepy words when he was on the Earth satellite and saw something. "These babies were huge, sir. Enormous. You wouldn't believe it. I'm telling you, there are other spacecraft out here, lined up on the far side of the crater's edge. They're on the Moon watching us." After that, he returned to the spaceship and flew to Earth. Yep, that smells like an urban legend for sure. In 2005, the commander of the International Space Station, Leroy Chiao, saw strange lights during a spacewalk. He described them as a set of white lights that rose from Earth and passed through him. His colleagues reported that it could have been an optical illusion caused by many fishing boats with searchlights along the coast of South America. Leroy saw the lights from the boats refracting and passing through his helmet. He doubted this version because he was at an altitude of 230 miles and the boats had to have some pretty powerful lights. But the astronaut was also skeptical about the extraterrestrial origin of these lights. One of the most common mysterious phenomena associated with space is glowing lights, but sometimes people notice something more material. For example, NASA astronaut Story Musgrave saw a tube that was flying in space, moving like a snake. He suggested it was a living creature from another planet or something like that. Of course, no one believed him. People assumed that the astronaut had seen some detached part from the ISS or a piece of space debris, like a hose or a tube. But the astronaut was sure that this tube had been moving like a living organism. However, the version with flying garbage sounds much more legit. During the Apollo 11 mission, astronauts reported strange light flashes in their eyes. The members of the Apollo 12 and 13 teams saw the same thing. The strangest thing was that they saw these flashes even with their eyes closed. After that, many astronauts reported seeing bright lights. They saw flashes before going to bed and in dark rooms. Some of them were bright, and some were dim and had different colors. During spacewalks, they repeated every few minutes. Scientists conducted experiments on Earth to figure out the nature of this strange phenomenon. As a result, NASA concluded that the astronauts had seen cosmic rays of an unknown nature. Researchers suggested that the particles of these rays directly affected the receptors of the retina. The astronauts' optic nerves felt the radiation, and their brains reacted to it with light flashes. During the Gemini 4 space mission, astronaut James McDivitt saw a strange geometric object in space, similar to a tin can with a pencil sticking out of it. As soon as the media found out about it, newspapers started claiming that James had seen a ship of another civilization. Then, a few years later, the astronaut refuted this theory. He saw some photos taken inside the ship and noticed the same tin can on it. It turned out that this was the reflection of some bolts in the window pane. By the way, this was one of the many times astronauts confused the details of the ship with some weird space stuff. In 1962, astronaut John Glenn was inside the Friendship 7 spacecraft when he noticed some strange things outside. They looked like tiny glowing fireflies. Glenn immediately reported this to NASA's command post. The dispatchers didn't know how to comment on this message, so the nature of the cosmic fireflies remains unsolved. But then, almost a year later, astronomers found out what it had been. At first, they thought the fireflies were pieces of metal torn off some part of the ship. But then they realized the glowing lights were droplets of frozen liquid that shifted and cracked in outer space. One of the strangest cases in the history of early space travel occurred during the mission of the Gemini 6 spacecraft on December 16, 1965. There were two astronauts, Wally Schirra and Tom Stafford, on board. They were preparing to return to Earth, but saw something strange in outer space. Wally contacted the Mission Control Center and reported he was observing an unknown object similar to a satellite. It was moving from north to south, somewhere in the polar orbit of the planet. The object was approaching them, and the astronauts could see the details. It was an unknown spaceship with a pilot dressed in a red suit. Wally heard through the radio that voices in the command center became tense. No one knew what it was and how to react to the unknown ship. Then, at that moment, they began to hear what sounded like music. Somehow, the song Jingle Bells started playing on the radio. Wally Schirra performed it on the harmonica, and the command center realized this was all a hoax. Schirra and Stafford cooked up this Christmas gag a few weeks before the flight. They wanted to cheer up their colleagues on Earth by saying they had seen Santa Claus in a spaceship. When Schirra finished the song, the guys from Earth relaxed and said it was too much. It's still one of the most famous jokes astronauts have ever played.
Well, it's not possible to cry in space, no matter how many heartbreaking soap operas you just watched. Even if you try really hard to weep, the tears just won't shed. They shed because of the gravity law, which works differently on a spaceship. Still, your lacrimal glands work as usual, so if you start crying, all the tears will accumulate right in your eyes. The more you cry, the bigger the tear clump gets. Basically, you can shed only one tear from each eye. But even if you don't cry, it's impossible to have a normal face in space. It'll be a bit puffy in brand new conditions. A nature's call is a nature's call no matter where you are. There are two reasons why astronauts can't flush the toilet in space. First, water is the most precious resource on a spaceship. Second, there's no running water in space. The potable water on a space station comes in pouches, and there it stays. For either number in weightlessness, there's a device with suction and disposable bags to put inside it. The storage gets changed every 10 days. Also, the ISS is equipped with a super complicated device that recycles and filters waste into the water the astronauts use every day. A sandwich, an avocado, and egg toast, a crispy croissant, chips. That's a short list of stuff you're never gonna eat in space. Sure thing, Zero-G will carry all the crumbs away while you're nibbling on a chocolate chip cookie. Those crumbs spread all over the spaceship in no time, and trust me, the best place they can end up is in your eyes. Otherwise, they can interfere with the spaceship equipment, which is something you don't want to happen. Astronauts have a variety of meals, including fruit, which can be eaten in their normal form, and pasta, which obviously requires some boiling. Now, nobody promised you an a la carte menu on a spaceship, but you can easily cook mac and cheese. Water and heating ovens are provided, as well as the rest of essential gear. Bad news? There are no fridges in space, so you can't save leftovers for tomorrow. Good news? You have a variety of condiments, ketchup, mayo, even mustard. They're actually very important. Remember, you can't sprinkle anything in space. It concerns salt and pepper, too. For the rest, astronauts' meals look very much like regular picnics with friends, somewhere in a peaceful meadow, but no campfire, guys. There's not enough oxygen for it, and you can't open the windows. One more thing you'll have to forget about when you travel to space is freshly brewed coffee to brighten up your mornings. There's just no way you can make it unless you want to spend the rest of your mission covered with ground coffee beans. Still, it doesn't mean you won't enjoy coffee at all. You'll just have to make do with its capsule version. It tastes pretty good, plus you'll get a lovely space view. Anyway, you aren't very likely to spot the difference between regular and space coffee. Food and beverages in space taste somewhat different, and many astronauts admit it all tastes so much stronger back on Earth. One of the reasons is that body fluids move differently because of zero-G, and instead of being where the legs are, they rise up to the head, blocking air passages. Also, there are many strong odors in the cabin which dulls people's senses, especially smell. If you ever spend a couple of months in space, hey, send me a text. You might want to shave, cut your hair, and certainly clip all your nails. But in fact, all the small hairs and cut nails are very much like breadcrumbs. Once you cut them, they start literally floating in the air, and you don't want your buddy's toenail to end up right in your face. Astronauts can use either a disposable razor or an electric one. If they use disposable razors, they first need to wet the skin. They squeeze a water bubble, catch it, and spread it all over their faces. The next step isn't much different from what they can do on Earth. You just need to apply some shaving cream. Then the shaving starts as normal. To get rid of hairs from the blade, they just clean it with a small bubble of water and a dry towel. They squeeze one more water bubble to wipe their face, and voila! They're clean shaven now. Things are a little different with electric razors. These devices have a special tool attached on top, which looks like a tiny vacuum cleaner. It takes care of all the unwanted hairs once they're cut. Astronauts clip their nails right in front of an air duct, which has a suction device to trap the nails. Sure, the nails bounce off while they're cutting them, so yeah, they gotta catch every single nail and put it down to the duct. The same air duct is responsible for refreshing the air on board. The nail clipper itself has a Velcro patch on it, not to lose it in zero-G. Now you're ready to play guitar in space. By the way, any loose items have Velcro patches to store them too. Now, on to the harder stuff. Since the mid-20th century, washing your body has gotten a lot easier than ever with the rise of home showers. That's true unless you're in space. Forget all those fancy shower gels and body creams. On a spaceship, you've got nothing but a no-rinse body bath pouch. To use it, an astronaut should fill it with 6 ounces of hot water and 2 ounces of cold water. This bag has a straw on top to squirt water bubbles out of it. One bubble in this slightly soapy water is enough to wash your hands. Once you're done, grab a towel and dry your hands. Then you can tuck it someplace to let it air dry. The good thing is that the evaporated water gets back to the station so the astronauts can reuse it. If you want to take a shower instead, you spread those soapy bubbles all over your body. No regular shower is possible on a spaceship. To try a space-inspired shower at home, try to do that with either wet wipes or measure 8 ounces of water, grab a towel, spread the water all over your body, and dry it. Refreshing, huh? Those who have really long hair, no worries. All you need are a no-rinse shampoo, a pouch of water, a comb, and a towel. Squirt some water onto your scalp and work it from the roots to the ends of the hair. Then add some magic shampoo and comb the hair. Add some more water if needed and dab the towel on your scalp to dry the excess. Actually, the towel helps get rid of grease too. Sounds bizarre, but the hair is squeaky clean once the astronaut's done. Brushing your teeth probably doesn't sound that challenging now. Wet the toothbrush, it soaks up the water easily. By the way, the toothbrush the astronauts use looks like a standard tube. Once you're done, open the tap, clean the toothbrush. Gotcha. You can't do that. So the only thing you can actually do is swallow the toothpaste. But there's nothing wrong with it. Astronauts say it's edible. The tube is standard, but the toothpaste you see in stores definitely requires rinsing. Don't try space-inspired toothbrushing at home. Astronauts can't sleep like people do on Earth. A cozy bed and dimness are inaccessible while you're on a spaceship. People in space see 16 sunrises and sunsets a day because their orbital velocity is about 17,500 miles per hour. Each sunrise and sunset lasts a few seconds, so there's not enough time to take a photo, not to mention falling asleep. All this messes up the sleep pattern, so astronauts have to learn how to fall asleep regardless of the sun. A sleep mask is a must, of course. Another problem is zero gravity. Also, when we lie down relaxing, our body temperature decreases, which is important for a quality sleep, but it's not possible in space. Some astronauts attach themselves to the walls in their sleeping bags, while others prefer to float. A good old ballpoint pen is useless in space. To use it, ink should flow, which doesn't happen if there's no gravity. A simple pencil is a no-go either. Once you sharpen it, you gotta deal with all the mess left behind. When people just started exploring space back in the 60s, they would use mechanical pencils to make notes. A space pen was introduced long before, in 1965. It had a cartridge pressurized with nitrogen, so the ink there is pressurized toward the tip. This pen can be used literally anywhere, underwater, in extreme sub-zero temperatures, and even during an exam. Bonus fact, if you're into baseball, don't travel to space. Even if your spaceship is large enough, chances are the ball will just float.
Imagine traveling to another planet on a journey that lasts for centuries, even millennia. Sounds crazy, right? Well, it might not be as far-fetched as you think. Scientists and engineers have been considering this possibility for a long time. And recently, a new study showed us how we can feed astronauts for as much as 6,300 years. Buckle up and let's find out what they learned. First of all, how do we feed people in space right now? Astronauts on the International Space Station, or ISS for short, can live there for several years. And they can't just pop out to grab a quick bite to eat. So what's the solution? Well, these astronauts have to rely on pre-packaged and dried food to keep them going. And no, they don't just eat astronaut ice cream all day, although that would be pretty cool. These meals are carefully planned for them to provide the nutrients and calories they need to maintain their health and perform their duties while in space. Currently, these astronauts consume about 4 pounds of packaged food per day. So the next time you get sick of your usual meals, remember that at least you're not eating the same thing for months on end in zero gravity. But these astronauts have been living in space for only a few years. Besides, they're still very close to our planet. Now, what about space adventures that last longer than your life? It's not as easy as packing a few ice cream sandwiches and calling it a day. Here, we face a number of problems. First challenge is the limited space available for food storage and production. Our regular methods of storing food, such as dried and packaged goods, aren't very practical for long-term space travel. Can you imagine how many jars we'll have to store to eat for centuries? Not to mention that after all these years, there won't be any vitamins in this food anymore. Another challenge is the limited resources available for growing and producing food. To survive on a closed spaceship, we need to recycle nutrients and resources like water and waste. So traditional methods of farming, such as using soil and large amounts of water, won't help us either. So what do we do? Don't worry, space pioneers, the answer might be space farming. That's right, folks, we're going to have to create a self-sustaining system. Astronauts of the future could be growing their own fresh foods, raising animals, and so on to feed themselves. We can also use traditional farming techniques to produce fish, dairy, and honey. Not only would this provide a yummy change from the usual dried space grub, but it would also help recycle nutrients, generate oxygen, and purify the air. Although there are still many challenges to be addressed, for example, how do we grow crops in microgravity? And how do we make sure the system stays self-sustaining over a long period of time? And most importantly, how can we fit it all in the cramped quarters of a spaceship? Actually, there's a possible solution for the last one. One way to maximize the use of space is through the use of aeroponics. This is a method of growing plants in which they can grow without soil. With the use of aeroponics, we can maximize the use of limited space. Pretty cool, right? As you can see, feeding astronauts isn't quite as simple as packing a lunch and heading out the door. But the good news is that we've already started testing these self-sustaining systems. There's a greenhouse in the ISS called LADA. It's been used to grow plants in microgravity since 2002. In this greenhouse, astronauts can grow fresh produce and herbs to mix things up a bit. Plus, it helps recycle nutrients and purify the air, helping to create a closed ecological system. It's basically like a little oasis in space. So right now, we're testing to see if this system could be used to sustain the crew on long journeys. Now, we know that the planets beyond the solar system are incredibly far away from us. So, how many years exactly would such a journey take? The closest exoplanet to us is called Proxima Centauri b. This exoplanet, or a planet outside our solar system, orbits the star Proxima Centauri. It's special, not only because it's just 4.2 light-years away from us, but also because it's located in the habitable zone of its star. In other words, it could potentially have conditions suitable for life. Scientists have even suggested that there could be liquid water on the surface of the planet, which, as we know, is a key ingredient for life. No wonder we want to visit this place one day, but the thing is, it would take about 6,300 years to get there with our current technology. So even though this planet is the closest one, this is a bit of a long flight. Not just a hop, skip, and a jump, you know? But let's imagine that we decided to go there now. We have thousands of years ahead of us. How will we evolve and survive in such a resource-limited environment? And, of course, how do we feed so many people since the ship is going to be multi-generational? That's the question that puzzled some European astronomers. Frédéric Marin, scientist at the Astronomical Observatory of Strasbourg in France, and his team decided to conduct a study on this topic. To answer our question, Marin and his colleagues used a numerical code called Heritage. And this is quite an interesting tool, the only one of its kind. This is a program code focused on multi-generational spaceships. It uses lots of scientific data and investigates their mathematical, biological, demographic, and statistical feasibility. Anyway, first, they calculated the annual caloric intake of the crew on board. Then, they compared it with our modern standards of agriculture. As a result, it turned out that in order to feed about 500 meat-eaters, we need about 0.2 square miles of farms. The study assumed that things like fruits, vegetables, starch, butter, and sugar would be produced by using aeroponics, which we talked about earlier. And ordinary farms will produce meat, fish, honey, and dairy products. And that's great! The results of this study are consistent with the forecasts of the Food and Agriculture Organization of the United Nations. Moreover, this is all taking into account aeroponics and microgravity. But some scientists believe that we'll need even less space. According to Mike Dixon, an independent researcher at the University of Guelph in Canada, previous studies have shown that if all these space travelers were vegetarian, they would only need about 8 square feet of land per person. This would include things like water recycling, oxygen production, and so on. So, if we cut out meat, we could take up less space and still maintain everything we need for life. This idea was picked up by Briardo Lorente, synthetic biologist at Macquarie University in Australia. He noted that in the future, we'll most likely grow food with the help of microbes. We're already gradually replacing animal meat products with microbe-produced foods. This way, we'll have delicious meat and won't have to bother with cattle. But the land area isn't the only problem that we'll have to face. For example, we know that plants grow slower in space. We can simulate things like light, temperature, and humidity, but gravity and radiation are much more complicated. We'll have to study these things for a long time to deal with them. Also, this new study doesn't address our most important problem, water. We more or less understand how to feed the astronauts, but what about drinking? We'll have to create a stable water circulation system inside the spacecraft. Marin and his team plan to address this issue in the future. They'll use the same code, Heritage, to find out how we can keep our entire crew hydrated for centuries. Anyway, it seems like intergalactic travels aren't as fantastic as they used to be. Of course, it will take years to make it a reality, but let's hope that one day we'll actually be able to grow tomatoes in the vastness of space.
You've been training for this for years. You know you're ready. You're standing on the door's threshold. You take a deep breath and bravely open it. You jump outside the International Space Station and into the vastness of space. Ah, this never gets old, you say on the transmitter device. You feel like a feather whenever moving through space. Except for the suit, of course. It's true what that guy told you one day. Astronaut suits, limit your body's movement by 20%. For you, that means you've got a 20% higher chance of being clumsy in outer space, which is never good odds. There's not a lot of room for error during a spacewalk. You finally get to the docking port. You look around and see the part of the station that needs fixing. This is where other space shuttles dock when they come in from Earth or other planets. About a week ago, a shuttle coming from Jupiter miscalculated the landing and broke a piece of the port. You've attached the new shield to your suit's belt. Now all you've got to do is screw it on the station. You've spent hours training underwater to do this. You wore a heavy, hot, uncomfortable suit inside a pool in order to get the training you needed. Incoming! Sarah shouts on the transmitter. You don't even have time to ask what, as an absurdly fast storm of space debris catches you off guard. It shakes everything around you. You try to hold on tight to the strap that's keeping you safe, but oh no! A piece of debris just hit your helmet shield. Come in, Bob, are you okay? Sarah asks you through the radio. You got a bit shocked by the impact, but everything seems fine. The meteorites are finally gone, so you can focus on your task now. You pull the rope that's connecting the new docking shield closer to your body, but the other part of the rope has nothing on it. Zip. Nada. Oh my, you think to yourself. Come in, Sarah, we have a lost shield. I repeat, we have a lost shield. This is a pretty serious situation, and you are aware of it. Anything that falls into space can go into a collision route with the International Space Station or with other space vehicles. You try to remember your training, but your mind goes blank. This is worse than that one time you broke your girlfriend's favorite ceramic jar. Sarah, the other astronaut who's with you on the ship, is shouting words on the transmitter. Oh no, Bob. Tell me you didn't do this. This is a total catastrophe. I'm coming outside. You spot the shield under the ISS. It's the size of a medium-sized car door, and it's moving quite fast. Here's what can happen in this scenario. The shield could head back down to Earth and break into the atmosphere. It would probably catch fire and disintegrate on the way down, but anyways, it would make NASA and you look pretty bad. The other option is the car door-sized shield gains momentum, and it orbits all the way to hit the ISS, and you for that matter, or some satellite that happens to be in a similar orbit. Here's the thing. If you ever thought that space was an infinite void, you got that part wrong. Since different countries started to build equipment strong enough to travel in space, space has been more crowded than ever. Not with people, but with satellites, asteroids, and space debris. You were surprised when you learned that Earth receives meteorite showers every single day, but they're so small that no one on the surface of the planet notices it. They usually turn to ashes before hitting the ground, but that's not all. What just happened to you on this mission has happened on several other missions before. Astronauts keep losing stuff in outer space. So much so that NASA had to create a division to track down and monitor the orbit of all debris that is just floating carelessly around. You couldn't believe it when someone told you that there are over 23,000 softball-sized pieces of debris roaming around in space, and if we're talking about smaller objects, then that number goes up to 500,000. As you were about to unstrap yourself and dangerously venture through outer space without any protection, you notice Sarah has beat you to it. You can't let her do this alone, so you decide to tag along. FYI, this is against every NASA handbook and training you ever received in your life. But you think, if this works in sci-fi movies, it must work for us. Even though we all know that's very far from the truth. Sarah's close to the debris shield, but her body weight makes her orbit in a completely different direction. Okay, you think to yourself, this is your turn to shine and be a hero. You try moving your arms like you would do underwater, but there's no friction in space. Duh. You can't butterfly swim your way to rescue the rogue equipment. You try to contact Sarah, but she doesn't come in. I guess you're on your own now. For some reason, you start to orbit in a similar route as the floating car door shield. It must be the amount of stuff you've got strapped onto yourself. Or maybe it was the breakfast burrito you had that morning. You feel like you're George Clooney in the movie Gravity. No, better yet, you feel like Obi-Wan Kenobi. Yes, you're feeling as strong and powerful as a Jedi right now. You keep your hands stretched before your body, hoping you'll gently collide with the space debris. And 3, 2, 1, and the landing was successful. Just joking, but yes, you managed to dock onto the debris. Hooray. Now what? You think? Guess you needed to have gone through that plan of yours a little bit more, huh? You still have no way of steering the debris. And now, you have no way to contact Mission Control and tell them the object, and yourself, are en route to somewhere. Don't get scared. You didn't come this far to get scared. What's the best thing you can do? First, take a mental picture of the Earth. It never disappoints from up here. Then, you try to play out the possible scenarios that could happen in the situationship you're in. Your normal body weight would not be enough to get you out of Earth's orbit. In the hypothetical scenario in which this did happen, you'd probably be vacuumed into Venus's orbit and spend a quite unpleasant period of your life around immense heat. Even though in Greek mythology, Venus represents love, there is nothing lovely about orbiting close to this planet, and you know this. If you got too close, your spacesuit would never be able to take on the heat. It's only made to sustain temperatures of around 250 degrees Fahrenheit tops, and Venus's atmosphere can heat up to 700 degrees Fahrenheit. But honestly, the worst-case scenario is much simpler than that. Your spacesuit could decide to drown your ears, nose, and mouth in water. Yup. This has happened on spacewalks before yours. You see, in order to keep your spacesuit chill and cool, the suit relies on a gallon's worth of water that makes up for a cooling system. This system, which is supposed to send recycled air into the back of your helmet, does leak sometimes. And since you're stranded in the middle of the big nowhere, you'd have only that nowhere to run. But wait, what's that popping up on the horizon? It's a modular space shuttle. You try shouting, but nobody can hear you outside your helmet. You wave with your hands. But it's coming straight at you. Finally, it took longer than I wished to find you, Sarah said. Apparently, she made it back to the space station just in time to catch you before you went definitely rogue. Guess I'll be losing some astronaut points for this little misadventure, huh? You say. And yes, you definitely will.
We interrupt this program to bring you this important message. The Earth is no longer fit for living, so you'll need to find your own new home. You immediately get the brilliant idea to apply for a job as an astronaut. You'll be able to wait over the hustle and bustle on the International Space Station until humanity finds a new home, right? The longest time a human has spent in space so far is 437 days and a few extra hours. And when I say in space, I mean the ISS, because a human being without the proper equipment in open space would only last a few seconds. The ISS is designed to support human life in space for extended periods of time. Extended, but not endless. The station gets resupplied with food, water, air, fuel, scientific equipment, and other necessities every 3 months. With no Earth or humans to send the mission, this lifeline will soon be broken. The station is a huge ship moving through space at over 17,000 miles per hour. It faces pretty harsh conditions, from radiation to micrometeoroids and huge temperature ups and downs. That's why the system regularly needs patching up. In addition to wear and tear, there are also unexpected events that can require resupply missions. In 2020, the crew discovered a leak that was causing a gradual loss of air pressure. They eventually found cracks in one of the modules. The crew managed to fix it, but it proves how important it is to have enough spare parts on board. Let's say the future humans will manage to find a way to run the station non-stop without restocking. Astronauts already grow plants in space in closed boxes with low-energy LED lights. It's not only a source of vitamins, without which humans can't survive, but a great mood booster. We'd also need more advanced closed-loop life support systems to recycle air and water efficiently. It's a system that captures carbon dioxide from the air by passing it through small beads. Then it uses steam to separate the carbon dioxide and transform it into methane and water. Water then divides back into oxygen. But even with all the possible advances, there's another problem: the health of the astronauts. They live and work in a microgravity environment, and they rely on carefully controlled life support systems. But our bodies aren't designed to live in weightlessness forever. It's like standing on your head, because the reduced gravity makes bodily fluids accumulate in the upper parts of your body. The result is a puffy red face. The gravitational force on the ISS is weaker than on Earth, so muscles don't have to work as hard and bones gradually lose their density. That's why each crew member follows a strict daily exercise routine. The heart muscle also weakens because it doesn't have to use as much effort to circulate blood throughout the body. Without Earth's protective atmosphere, astronauts are continuously exposed to cosmic rays. They are invisible waves that can cause some serious health issues. So maybe we're better off opting for Mars or the Moon for an alternative home.
There's a strange noise coming through the speaker.
2 astronauts are stuck in space right now. It all started when they heard this creepy, pulsing sound coming from inside their spacecraft. A noise that shouldn't even be possible in the vacuum of space. The situation got so strange that their return trip from the International Space Station was cancelled. What was supposed to be just a few days in space has turned into 9 months of a real nightmare. This situation is happening to NASA astronauts Butch Wilmore and his colleague Sunita Williams. On June 5, 2024, they left Earth with one mission: to spend about 24 hours traveling aboard the Boeing Starliner spacecraft until they reached the space station. They were supposed to stay there for only 8 days, working alongside the 7 astronauts and cosmonauts already aboard. After that, they'd head back to Earth on the Starliner. Simple as that. However, just as they were getting ready to return to Earth, something strange happened. Wilmore started hearing this bizarre noise inside the Starliner capsule. It sounded like a heartbeat, with steady intervals. The creepiest part is that space is supposed to be totally silent, since there's no medium for sound to travel through. There are no atoms or molecules to carry a sound wave, so there's no sound or echo. And no one can hear you scream. It is just total silence. So there's no way those weird sounds could be coming from outside the spaceship. The situation got pretty concerning, as the noise just wouldn't stop. On top of that, the astronauts couldn't figure out where it was coming from. I mean, they knew it was coming from a speaker inside the capsule, but they had no clue what was causing it. So, they decided to ask the experts at the Johnson Space Center in Houston for help. Before we continue, it's important to know that odd sounds in spaceships aren't uncommon. Back in 1969, when the Apollo Mission 10 entered lunar orbit, astronauts said they heard a mysterious music coming from the far side of the moon. It was like a whistling sound that lasted almost an hour. It was so bizarre that they thought no one would believe them. Specialists think the sound was caused by radio interference, maybe from a magnetic field or atmosphere. But here's the thing. The moon has no magnetic field and not enough atmosphere to cause these sounds. So, the mystery still stands. Something similar happened back in 2003. Chinese astronaut Yang Liwei was on his first trip to space, alone, aboard a tiny spacecraft, when he started hearing something weird. It sounded like someone knocking on the spaceship's body, almost like knocking on an iron bucket with a wooden hammer. But what was even stranger was that the sound didn't seem to come from either outside or inside the spacecraft. Li Wei never figured out what it was, not even after returning to Earth. The situation was eerie enough to freak him out, probably just like what happened to Wilmore and Williams. But in the case of the NASA astronauts, it looks like they found an answer to the creepy sound. According to the team at Mission Control, the sound was probably just a technical issue. They think it's a speaker feedback loop between the space station and the Starliner. So, that sounds like great news, right? Well, not exactly. Their problems were far from over. The audio issue was definitely a concern for the team at the Johnson Space Center, but honestly, there were a lot of other technical issues going on with their spaceship. Even before the launch, experts noticed a small but persistent helium leak. This could be a big problem because this gas powers the thrusters, which control the spacecraft's orientation, speed, and trajectory. But in this case, the specialists thought, nah, it'll be fine. The leak was at an acceptable level and posed little risk to the mission's success, so they decided to go ahead with the launch. But then, things got worse. Once the astronauts were in space, specialists noticed another helium leak, then another, and another. In the end, they found 5 leaks, which had the mission managers pretty worried. So they urgently contacted Wilmore and Williams. The astronauts were about to go to sleep when they got the order to shut down 2 valves on the spacecraft. That way, it would be safe again and still have plenty of helium left to get them home. And when they thought it was all over, turns out it wasn't. The Starliner also had issues with the thruster control system. The capsule had 28 small thrusters, and 5 of them had technical problems at some point during their trip. 4 of the thrusters were fixed pretty quickly, but one of them never worked again. So first, there were the helium leaks. Then the thrusters weren't working properly. And now, there's this weird pulsing sound coming from inside the spacecraft. It seems like the problems with the Starliner just kept piling up. Suddenly, it became way too risky to bring the astronauts home. That's why NASA decided to cancel their return trip. Actually, they delayed it, extending their 8-day stay on the space station to 9 months. So far, they're expected to come back to Earth in March 2025. But it's hard to say for sure, since this date has already been pushed back before. What we know for sure is that both astronauts are stuck in space right now, waiting for the NASA SpaceX Dragon spacecraft to bring them back to Earth. Until then, they're sharing their floating home, which is about the size of a 6-bedroom house with 7 other people. Being stuck in an orbiting laboratory and unable to get home is definitely a desperate and suffocating situation for most of us. But it looks like they're handling it pretty well. Both of them had already done 2 long-duration stays in orbit before, so despite their families, both astronauts are used to it. And they said they're grateful for the extra time in space. Before the mission began, NASA also made sure they understood all the risks of the flight, including the chance they might have to stay at the station longer than planned. That's why both Wilmore and Williams fully supported the new date for their return to Earth. And they've been keeping their minds pretty busy up there, doing a lot of scientific work. One thing they're really focused on is looking after the plant facility at the space station. Their team is testing different techniques to see how they could help crops grow outside Earth. Figuring out how plants grow in space and making sure they get the right amount of water and nutrients is really important, especially as space travels keep going farther and farther beyond the moon. A lot of people are concerned about their safety and health, but there's no need to worry. They're completely fine. Stays on the space station usually last about 6 months or more. Also, the place is well stocked with everything the crew needs, including food, water, clothes, and oxygen. NASA and its partners often send missions with extra supplies to make sure everyone feels safe and taken care of. If Wilmore and Williams feel homesick and have some free time, they can always email, call, or video chat with their family and friends. The Boeing Starliner spacecraft returned to Earth on September 2024, but it came back empty, without Wilmore and Williams on board. It traveled in autonomous mode after undocking from the space station. The Starliner re-entered Earth's atmosphere after 6 hours of travel, using parachutes to slow its descent before landing at the White Sands Space Harbor in New Mexico. The landing was a success, but NASA specialists wish it could have gone as originally planned. I mean, with Williams and Wilmore on board. Now, all we can do is hope they have a safe trip home. The profession of an astronaut is probably one of the most intriguing and mysterious out there. But have you ever wondered about the details of their everyday life? Like what's going on under those bulky spacesuits? I mean, some people seriously believe that astronauts wear paper underwear. Others are sure that a lack of gravity allows the grime to just float away. If only. The thing is, astronauts don't do laundry at all. In 2011, NASA commissioned a washing machine for the International Space Station. Was it a joke? In any case, astronauts couldn't use it for apparent reasons. Delivering water to the ISS just to do laundry sounds outrageous and super costly. So, astronauts can only dream of freshly laundered linens and other stuff. Instead, fresh clothes get delivered to the station from Earth just like any other supplies. Unfortunately, it happens not that often since the price of launching literally anything into space is exorbitant. So, astronauts have to wear their clothes for way longer than they would otherwise do on Earth. The only thing that makes this situation a bit better is that astronauts tend to lose some of their sense of smell in space. When interviewed, some astronauts admitted wearing, for example, the same pair of shorts for months and only changing their underwear once every 3 or 4 days. It's probably not surprising that astronauts dress not to impress, but for comfort and convenience. Their typical attire usually consists of short-sleeved shirts and long cargo pants. Those are regular clothes we wear on Earth, nothing special. But when they leave the climate-controlled insides of the ISS, of course, they need special clothes. By that, I mean those very chunky spacesuits. They protect astronauts from insane temperature swings ranging from 250 degrees Fahrenheit in the sun to minus 250 degrees in the shade. But even with all this protection and cooling tubes wicking away body heat, spacewalks tend to cause astronauts to work up a sweat. Wearing an EVA, which stands for extravehicular activities, can mean hours of hard work. And don't forget that astronauts often wear layers to stay warm and pressurized. And these layers include an inner form-fitting item of clothing that resembles long underwear. This item is often reworn and even shared. And since there are no washing machines on the ISS, you get the point, right? An interesting fact: there is a specially trained person who smells every single thing that astronauts take with them into space. It's done to protect them from unpleasant or toxic odors. The thing is that you can't really air the room out there in space if you don't like how it smells inside. That's why NASA is very careful about what kind of odors can pass through. At the same time, nothing can prevent the smells that appear already on the ISS. Anyway, spacesuits and what's underneath them are used again and again, and soon you start worrying not only about bad smells, but also about hygiene and health problems. An alarming possibility of biocontamination arises. It includes bacteria, body fluids, and other foreign substances. It gets worse if we think about longer missions, for instance, to the moon. At the same time, it's totally impractical to wash spacesuit interiors on a consistent basis. Water is too valuable on the ISS to waste it on something so mundane. That's why NASA, along with the European Space Agency and other organizations, asked specialists to develop fabrics that could solve the problem of biocontamination in suits. You see, during the shuttle program conducted by NASA, spacesuits were supposed to be used on quite short 2-week trips. But then, astronauts started living on the ISS for much longer periods of time. That's why the spacesuit's lifespan had to be extended up to 6 years. No wonder microbes became a much more worrying issue than before. So more than a decade ago, a team of experts began to research different methods of getting rid of microbes and bacteria dwelling in spacesuits. They cut textiles in 2-inch squares and put them in petri dishes and grew a few species of fungi and bacteria on these samples. Some of the fabrics they used were infused with copper. This substance has impressive antimicrobial properties. When bacteria touch this element, their cell walls and membranes get destabilized. The metal's ions damage microbes, making them more vulnerable. NASA scientists also tried using textiles treated with silicone and silver. The latter turned out to be as toxic to germs on contact as copper. After observing the stuff that had grown on the fabrics for the past 14 days, the researchers discovered that only one compound had managed to keep bacteria and fungi at bay. It was a solution of silver molecules normally used for disinfecting hospital dressings and other stuff. But the ions of this metal turned out to be too good at their job because they got rid of everything, literally. And total sterility could do more harm than good. We need a balanced ecosystem consisting of millions of microorganisms to keep our organs and skin healthy. In 2022, NASA hired U.S. companies Axiom Space and Collins Aerospace to develop the next generation of spacesuits. And soon, a prototype suit appeared. It was designed to be used during the Artemis 3 mission. The main goal of this voyage is to land a crew at the South Pole of our natural satellite. These spacesuits are supposed to use textiles with antimicrobial properties that can potentially reduce biocontamination. The cooling system of these suits will also add biocides in its water loops, which will help prevent microbial buildup. Now let's talk about spacesuits in more detail. To begin with, there are actually two main types of spacesuits. You've probably seen the Advanced Crew Escape Suit, aka the orange suit, aka the pumpkin suit. Astronauts wear this full-pressure suit during takeoff, or rather liftoff, since we're talking about a spaceship. These suits are irreplaceable for those who are heading for super high altitudes. There, the pressure is so low that people can't survive without a special protective suit. And while air crews wear partial pressure suits, space crews have to be protected by full pressure suits. After all, they travel way, way higher. The suit is also equipped with lots of things that can help an astronaut survive emergencies during a spaceship launch or landing. A regular pumpkin suit is stocked with flares, medications, survival gear, a radio, and a parachute. So, in short, astronauts couldn't live through the process of leaving Earth without the orange suit. But why did its designers choose this hue? The main reason for picking the orange color is that this hue is one of the most visible for search and rescue, including very probable sea rescue. As for EVAs, their purpose is different. Astronauts wear these suits when they set off on spacewalks. It can protect them from the severe conditions of outer space, with its extreme temperatures and near vacuum. Plus, the spacesuit can prevent small debris from hurting space travelers. You've probably noticed that EVA suits are much bulkier than the orange ones. That's because they have many layers of insulation and heavy protective fabric. They also contain breathable air, drinkable water, and temperature controls. Now, every time an astronaut goes on a spacewalk, they use a tether that ties them to the space station. And in case the tether breaks, the EVA suit has a backup system. This system includes small jet thrusters which can be controlled from the station with the help of a joystick. As for the color, first of all, white reflects the heat of the sun better than other colors, and astronauts don't get too hot. Plus, the white color is the best when it comes to spotting the tiny dot of an astronaut against the vast expanse of black space. Another curious detail. While white spacesuits protect astronauts from getting too hot, they can't prevent them from getting too cold. And that's when special gloves come into play. They have special heaters which keep astronauts' fingers cozy and functioning. This terrifying but very much real image emerged just recently. In it, you can see something that looks like it belongs in a science fiction movie. From far above Earth, aboard the International Space Station, an astronaut captured something astonishing over Louisiana. A gigantic jet blasting upward straight into the sky. It looks as if Earth is sending a signal skyward. Can science explain this eerie phenomenon? Apparently, it can. This energy blast is called a gigantic jet, and it's one of the rarest and most powerful kinds of lightning we know about. Unlike regular lightning, which strikes down toward the ground, gigantic jets shoot up from storm clouds, and they can stretch for more than 50 miles into the sky. Sometimes they even reach the ionosphere, the layer where Earth's atmosphere starts blending into outer space. To give you an idea, space officially starts around 62 miles above sea level, and the ionosphere stretches from about 50 to 400 miles up. Shockingly, scientists have only known about gigantic jets for about 20 years, and we're still figuring out exactly how they work. One theory is that something inside the storm cloud blocks the lightning from escaping downward. So all this pent-up energy looks for another way out and ends up blasting upward into the sky. But honestly, we still don't fully understand why it happens. Gigantic jets are also extremely rare. Scientists think that they happen only around 1,000 times a year on the entire planet. And when they do happen, they carry a lot of energy. We're talking more than 50 times the power of a normal lightning bolt. The strongest gigantic jet ever recorded happened in Oklahoma in May 2018. It was intense, reaching a temperature of 8,000 degrees Fahrenheit and releasing about 60 times more energy than regular lightning. In other words, it was a huge burst of electricity flying straight into the sky. Most of the photos we have of gigantic jets come from satellites or astronauts on the International Space Station. But a few have also been captured from airplanes flying over storms. The latest jaw-dropping image was taken on November 19, 2024, by an astronaut aboard the ISS. At first, the picture wasn't released by NASA or any space agency, but one photographer, known for tracking and photographing rare lightning events, found the photo by accident. He was browsing through a NASA-run website called the Gateway to Astronaut Photography of Earth, which hosts photos taken by astronauts. There, he spotted images showing a giant lightning jet. Eventually, the photos were brought to public attention on February 26, 2025, and they've also been turned into a time-lapse video on YouTube. We still don't know exactly about the exact spot where the jet happened. Thick storm clouds covered the ground in the pictures. But based on where the ISS was flying at the time, the jet probably happened just off the coast of New Orleans. Speaking of other images of the gigantic jets, a photographer living in Puerto Rico was taking pictures of a storm moving through the area. That same storm would later grow into Hurricane Franklin. While watching the skies, he saw something truly amazing. Several massive lightning bolts shooting straight up out of the storm clouds, stopping just below the edge of space. No wonder. According to a 2022 study, gigantic jets happen most often in tropical areas, and they're more likely during fast-growing storms, like Hurricane Franklin. Gigantic jets often end with thin, red, branch-like lightning tendrils. These faint red flashes are very similar to another rare type of lightning called sprites. Those sometimes look like giant glowing jellyfish in the sky. In 2023, an astronomer named Stanislav Kaniansky in Slovakia captured one of the clearest images of a sprite ever. It happened during a thunderstorm over Central Europe on August 14th, and he spotted it near his home. In the photo, you can see a huge glowing red structure with zigzag patterns stretching over 31 miles across the sky. But like all sprites, it only lasted a fraction of a second before fading away. Sprites happen when lightning sends electrical energy upward into the upper part of Earth's atmosphere, instead of just downward like regular lightning. This energy creates glowing strands of plasma, which is basically electrified gas, way up in the ionosphere. Since sprites are so fast and often hidden by thick clouds, they're very hard to photograph. But Kaniansky got lucky. The thunderstorm was about 200 miles away from him, so he had a clear view just above the tops of the storm clouds. That perfect angle helped him capture this stunning phenomenon. There are many different kinds of lightning, and some of them are not only rare but also super dangerous. Let's take ball lightning, for example. It's exactly what it sounds like, a glowing, floating ball of light that appears during thunderstorms. It's also one of the weirdest and most mysterious forms of lightning. People have seen these strange light balls, usually about the size of a grapefruit, slowly spinning or hovering just above the ground. Some even say they've seen them float through closed windows or suddenly appear indoors, then vanish after about 10 seconds. For hundreds of years, no one really knew what caused ball lightning. Scientists had no explanation, and most sightings were based on eyewitness stories. Then, in 2012, someone finally managed to capture ball lightning on camera. Since then, different ideas have come up to explain what ball lightning really is. One of the newest theories suggests that the ball is actually a tight bubble of super compressed air. This compressed air bends and spins white light in all directions, making it look like a glowing ball rolling around in the sky. And according to the researchers, ball lightning can be almost 1 billion times more intense than regular lightning that moves in a straight line. Then there are elves. They look a lot like sprites, but instead of looking like jellyfish or dancing shapes, elves appear as huge glowing rings or halos in the sky. And they're massive. An elf can spread out to be up to 185 miles wide. You can even spot them from space or through thin clouds during the day. Dark lightning is probably one of the strangest types of lightning. and most people don't even know it exists. Unlike regular lightning, it doesn't produce a bright flash. Instead, it gives off intense bursts of radiation, especially gamma rays, the most energetic form of light found in nature. Dark lightning happens when high-speed electrons slam into air molecules inside a storm cloud. This creates a burst of gamma rays. They're so strong that they can mess with satellites hundreds of miles away in space. In rare cases, when a plane flies through a thunderstorm, these flashes can hit the aircraft. Some passengers could get a quick dose of radiation, about the same as a full-body CT scan. But worry not. Scientists say these occasions are extremely rare and not a reason to be afraid of flying. And finally, there's positive lightning. You see, lightning is still kind of a mystery, even for scientists. But here's the basic idea. Inside a storm cloud, tiny pieces of ice bump into each other and build up electric charges. Some become positive, others negative. Most of the lightning we see comes from the bottom of the cloud, where there are lots of negative charges. These reach down and zap the ground. But sometimes, lightning comes from the top of the cloud, where positive charges hang out. That's called positive lightning, and it only makes up about 5 to 10% of lightning strikes. Most of the time, those positive charges just zap other parts of the cloud. But sometimes, they shoot all the way down to the ground. That's why positive lightning can strike even when the sky looks clear, because it comes from way up high in the cloud, sometimes miles away from the storm itself. The scariest part is that regular lightning can reach about 300 million volts, while the charge of positive lightning can be up to 1 billion volts. That means positive lightning is much stronger and more dangerous.
Just watching certain scenes from the movie Gravity was scary, let alone imagining what would happen if you really ended up in the cold, endless void called space without knowing if you'd be able to go back. But let's say you're really up there. You're so excited about your first spacewalk. It sounds risky, but it's something astronauts on the International Space Station do quite often. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. That's why they go through pretty intense training sessions, so they can remain calm even in very stressful situations. A long time ago, NASA would choose astronauts from test pilots who went through harsh training in the jungles of the Philippines without any help, so no instructions or supplies. Later, they implemented a special training regime with outdoor exercises in different climate environments and even underwater to simulate conditions in space. Today, astronauts are trained to work in teams to stay focused and calm while handling difficult tasks. For instance, when they needed to fix the Hubble telescope, astronauts had to work for more than 8 hours in the harsh conditions of space to remove a broken part. It was a frustrating task. Plus, the gloves they had to wear made things harder, but they still did it. They also train in a giant water pool in Houston, which is a pretty good replica for the ISS. That's where they practice spacewalks and try to repair things while being underwater all the time. The water makes them feel weightless, while their suits are heavy enough to mimic the effects they could experience during spacewalks. You also need to have sessions with aerospace psychologists. They help astronauts handle stress and stay mentally strong. They check astronauts before, during, and after missions, helping pick the best candidates for spacewalks. Not everyone can go through these harsh conditions. Out of 16, only 10 get chosen. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. When up in space, a lot of things can go wrong, and sometimes even astronauts' training and equipment can't help solve the problem. That's where the Mission Control Center on Earth jumps in. Thousands of people work on Earth to support the astronauts on the ISS. But if the communication system doesn't work, or no one's close enough to help, that's where the rescue operation stops. You just continue to move in a random direction, waiting for the 7.5 hours of air you have to run out. Feeling hungry? Unfortunately, you can get nothing but some water you have in your helmet. Maybe you'd stop spinning at some point. The view would be fascinating. You could watch the Earth rise and set about 5 times, depending on where you are. And while you'd be getting farther away, and Earth would be turning into a small dot lost among asteroids, stars, and space debris, a random picture would come to your mind. A stunning sunset at the beach, the sound of waves, and your favorite pizza. Now, it's so far, it almost seems like part of another dimension. Well, your childhood dream is coming true. You've been selected as one of the volunteers to go to space as a tourist. It's time to pack your bags. Must check the airline. Strike that out. Make it spaceship luggage restrictions. And trust me, the low-coaster airline rules down on Earth are nothing compared to the do's and don'ts for the International Space Station. A regular mission to the ISS lasts 6 months, so any ship going up there brings supplies for the astronauts already there. And it's not just some vital materials to keep the mission running, but also crew care packages. Those are meant to make life among the stars more comfortable and include something nice from the crew members' homes or the support staff. There's a weight limit of around 11 pounds, and the size of the package is 9 by 16 inches. Food can be inside, but anything that can produce crumbs isn't welcome. Perfumes, aftershaves, mouthwash, and anything in pressurized cans like shaving cream aren't allowed. And in case you were wondering, video games can't be in your crew care package. There could be some problems with batteries up there. So no video games for months? I might reconsider my astronaut career. Clothes are good to go, but only if they're 100% cotton. One more thing that takes off with the spaceship is an official flight kit. It has around 120 pounds of flags, patches, stickers, and other merch. And no, it's not for sale in case we do find life on Mars. These items from NASA, commercial partners, and international organizations are supposed to come back to Earth to be used as souvenirs, museum exhibits, or awards. And, of course, you'd have to send NASA an official request, and they'll decide which items and how many can go. Now, life in space would be sad if you can't bring something that reminds you of home, right? Well, NASA's got you covered. You can also bring a personal preference kit on your mission. Don't get too excited though, it's just around the size of a lunchbox and can fit a bit over 3 pounds. PPK was introduced during the Gemini program, when 2 people could fit into a capsule instead of 1 like before. Back then, personal items had to go inside a gray nylon bag with a drawstring. Astronaut Wally Schirra chose to pack his bag with 20 gold medals, 5 silver medals, flags, patches, and a Florida hunting license. I wonder what plans he had for his time in space. His colleague, Michael Collins, who went on the first mission to the moon, brought 3 flags with him, among other things. Years later, he took part in a NASA poll on Twitter and shared that he wished he had brought coffee and a good book to read. The more popular choices for PPK are family photos, ball caps, t-shirts, pins, and other things with logos of universities or teams and other memorabilia that mean something to them but remain a secret. Many crew members also bring musical instruments that later stay on the space station. One astronaut even got an alto saxophone for his birthday in space. That one must have been tough to hide. Another popular carry-on choice is camera gear. The views up there are too good not to capture. So, you finally choose the particular photos of your relatives to take with you and which should stay on Earth. You reach the ISS, embrace its residents, and naturally, your next wish is to take a shower after the trip. But don't get your hopes up. Water doesn't flow in zero gravity, so you won't be able to take a refreshing shower up there. Plus, water is pretty heavy, and it would be pretty expensive to send rockets filled with it into space. So, astronauts use pre-moistened wipes or towels with liquid soap to wipe their hands and faces. Another wet towel can serve to clean the rest of the body. But what about hair? Well, meet your new friend, the rinseless shampoo. You can't let splashes of water escape and mess up the electronics, so you gotta use a straw-like nozzle to run the water through special bags made of foil and plastic. Most of the water used for it goes back into the air conditioning system. It gets filtered and recycled to be used for drinking. Now, astronauts do brush their teeth, but even that simple task requires some skill in space. You'll need to attach the toothpaste tube to a wall and then squeeze a tiny bead of water over the toothbrush. Then you can brush your teeth like you do on Earth, squeeze some more water, and wipe it off with a towel to clean the brush. And oh, there's no sink to spit into, so you'll have to take a couple of sips from your water bag and swallow the toothpaste with it. Boy, sign me up. All that space routine has worn you out. Time to replenish your energy supplies. Luckily, space food is no longer mashed up in a tasteless mix and packed in tubes we've all seen in movies. Space food advanced along with space technologies, and now astronauts have a diet similar to yours down on Earth. They can eat fruits and brownies in their usual form. When someone on the ISS wants to snack on mac and cheese, they just need to add some water to it. There are no fridges up there, so you can't bring your favorite ice cream, and all other foods must be properly stored. It mostly comes in plastic packaging or cans. To prevent your meal from flying away, that packaging comes with Velcro patches and can be attached to a tray or table. There's a convection oven, so those lunches among the stars won't be as cold as outer space. Astronauts get 3 meals a day, and nutritionists make sure they're all well balanced. You can choose between coffee, tea, orange juice, fruit punches, and lemonade when you feel thirsty. Fizzy drinks don't fizz in freefall, so you can't bring soda. There's ketchup, mustard, and mayo to spice up your diet, but the salt and pepper only come in liquid shape. Otherwise, they clog the air vents and other equipment or get stuck in the astronauts' eyes, mouths, and nose. Yep, we already know crumbs aren't welcome in space for the same reason. But what about bread? One option is to replace it with tortillas. Another option is to sneak a sandwich on your spaceship without anyone knowing. John Young tried it once, but the crumbs were a disaster, so he couldn't enjoy his corned beef sandwich at all. You could also wait for the scientists to find a solution. They've been working on it for a while. A German company called Bake in Space teamed up with the German Aerospace Center and a bunch of researchers to create the perfect dough and find a way to bake it right in space. They need a special oven, and its surface shouldn't heat up over a certain temperature. So far, the astronauts have successfully baked cookies on the ISS. It took way longer than it would in a regular kitchen, but the result was worth the wait. The whole station smelled like cookies. Speaking of smells, they can hang on for years in the space station, and you just can't open the window and air the room, you know. So even a non-toxic material can give off odors that could tamper with the astronauts' work or even make them sick and put the mission at risk. That's why NASA has its own chief sniffer, also known as Nostradamus. His work is to smell all objects that will be in the habitable zone of the ISS. Now, you can't wait to journal about everything you've learned. Too bad pencils aren't welcome in space. The lead could easily break off, float away, and cause some major drama. A regular pen wouldn't work in weightlessness, so a special pressurized space pen premiered back in 1968. There are around 80 models of it now, and dozens of them are currently floating on the ISS. It's been one busy day in space so far, and your mission is just getting started. Now, as a child, weren't you taught not to play with your food? Well, apparently these astronauts weren't. Floating Jell-O cubes across the cabin while in zero-G is a lot of fun, but it is also a sign of a potential problem called space euphoria. No one ever considered that extreme happiness in space could become a severe problem, but it can become a serious problem, and that's no kidding. For many years, space euphoria went undetected, although it was right there, front and center for all to see. When Apollo 14 astronaut Alan Shepard smuggled golf balls onto the moon and tried to create a tiny moon for the moon by attempting to hit a golf ball into orbit around the moon, everyone thought it was funny. Apollo 16 astronaut Charles Duke thought it would be funny if he tried to compete with the 1972 Olympic athletes back on Earth. He attempted to outjump the Olympic athletes to benefit from the 1/6 gravity on the moon. Duke jumped so high that he rotated onto his back and fell crashing onto the life support system in his backpack. It could have been a fatal fall if the bag had cracked. Duke's commander, John Young, said, "That's not funny," and it sure wasn't. Yet, when Apollo 17 astronauts began dancing and singing children's nursery songs while collecting rock samples, everyone still thought it was cute. Space euphoria again went unnoticed. As early as 1965, when Ed White became the first American to walk in space on a tethered spacewalk, his space euphoria became evident. He stayed out much longer than was necessary to test his mobility with the very first jetpack, or MMU as it was called, officially the Manned Maneuvering Unit. In his own words, "I'm not coming back. This is fun." Finally, when ordered to return to his Gemini spacecraft, Ed White said it was the saddest day of my life. Obviously, something sinister is at work with space euphoria. Weightlessness, combined with the view of Earth passing below, creates an exhilaration that overcomes all sense of duty. It is the great danger of space euphoria. Now, in hindsight, the effects of space euphoria could be seen when Apollo 17 astronauts drove the lunar rover on the moon. They exceeded the recommended speed limit and could be heard whooping and yelling as the rover rocked onto two wheels, even becoming airborne at times. Canadian astronaut Chris Hadfield was busy at work during his tethered EVA, extravehicular activity, when he paused to look over his shoulder. The glory of space smacked him in the face. He was so emotionally overwhelmed at the magnificent beauty of the Milky Way galaxy that tears began to fill up Hadfield's eyes. Now in space, tears do not flow down your cheeks. They pool up in your eyes. Hadfield had become blinded by tears of joy. But Hadfield, against protocol, refused to tell his supervisors on Earth. Only after he was no longer able to work did Hadfield speak a famous quote, "Houston, I have a problem." It was a direct result of space euphoria. Astronaut Hadfield managed to get back into the space shuttle, but his EVA was not fulfilled. Space euphoria had interfered. There is another aspect of space euphoria that deserves serious attention. It is something called the overview effect. Weightlessness in space affects everything from the physical and psychological health of the astronauts to the physics of using all the mechanical equipment of the spacecraft. However, weightlessness in space is not due to a lack of gravity. Astronauts orbit Earth less than 300 miles up, called LEO, low Earth orbit. There's plenty of gravity in low Earth orbit. The Earth's gravity keeps the Moon in orbit, and the Moon is about 250,000 miles away. In fact, a 150-pound astronaut would weigh 142 pounds in LEO. Weightlessness in space is due to free fall, not lack of gravity. What goes up must come down. The rocket blasts off, and about 8 minutes later, the engines shut off. The spacecraft begins to fall back to Earth. Fortunately, by this time, the rocket has achieved orbital velocity, which is about 17,500 miles per hour, so that it falls towards Earth but never hits the Earth. It keeps falling and falling around and around, precisely in the same curved path as the surface of the Earth. It's in orbit. It is free fall. Even though everyone calls it zero-G, it's not. If you were to place a bathroom scale under your feet when in free fall, it would show 0. You would weigh nothing. That's because the bathroom scale is falling too. The exciting thing is that astronauts retain all their muscle power. Their mass stays the same. Therefore, they can lift heavy equipment in space that would weigh hundreds or even thousands of pounds on Earth. Astronauts become superhumans in space, and that creates another unusual situation. There are lots of unusual situations in space. On the very first trip to the Moon, the Apollo 8 astronauts were not even scheduled to look back and photograph the Earth. Apollo 8 astronauts took only a limited number of pictures of Earth. That's unusual and kind of weird. But Earthrise from the Moon became perhaps the most influential environmentalist picture of the 20th century, and it wasn't even planned. But this is the key to understanding the overview effect: surprise at the unexpected. Even today, almost all globes of Earth are not of Earth. Globes in schools and libraries show each country, usually in different colors. Each country, sure enough, contains a star, but it is to mark the capital city of that country. It is not how the Earth looks from space. These globes are not globes of the planet Earth. In fact, it isn't easy to even find a globe of the planet Earth. Read the labels on these classroom globes. The geopolitical world. These are globes of a place called the world. There is no planet called the world. The world does not live in space. It lives on someone's desk or shelf. The definition of space is geological in origin. Space is defined as existing up to, but not including, the atmosphere of Earth. Earth isn't even an astronomical object. It explains why the very first mission to the Moon, the Apollo 8 mission, had not scheduled any pictures of Earth. Selfies weren't invented then. It also explains why the psychological impact of seeing Earthrise from the Moon was so profound. It was a unique and totally new perception for which any and all humans were utterly unprepared. Seeing Earth in space was a complete surprise. Imagine yourself floating in space outside the spacecraft. You are surrounded by the Milky Way galaxy blazing with millions of stars. The planet Earth is a blue marble passing beneath your feet. Pretty heady stuff. How would you react? Would it change you? Apollo 9 astronaut Rusty Schweickart felt strongly that he was what he called the sensing element for humanity. What does he mean? It's the overview effect kicking in. Schweickart felt that he was connected to all the people on Earth. He compared it to being born into a new existence. And astronaut Schweickart is not the only one who felt the overview effect. Apollo 14 astronaut Edgar Mitchell had this to say about being in space. It was rather an extension of the same universal process that evolved our molecules, and what I felt was an extraordinary personal connectedness with it. I experienced what has been described as an ecstasy of unity. I not only saw the connectedness, I felt it and experienced it sentientally. I was overwhelmed with the sensation of physically and mentally extending out into the cosmos. Some years after returning from space, astronaut Mitchell started an institute to study the brainwaves of people who had been in space. And yes, they are different. According to Mitchell's institute's research, the euphoric sensation of oneness with the universe creates brainwaves similar to meditating monks. Mitchell's studies were so significant that NASA launched a special Space Shuttle mission in 1998 just to study the effects of space on the brain. The Neurolab mission studied brain cells of laboratory animals, and the astronaut crew too, as brain cells try to adapt to the freefall environment in low Earth orbit. Well, we can't all be astronauts, but now we can all access virtual reality experiences of what the astronauts saw in space. The internet has opened up our earthbound point of view to share the unity and oneness of the overview effect, and give us a small taste of the space euphoria astronauts get in space.
Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of sound effect, which is a totally false misconception. In space, no one will hear you scream. There's no air in space. It's an almost perfect vacuum. And the sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Huge space explosions sure look super impressive. Whether they're scientifically possible or not is another question. Blasts on our home planet look the way they do because of air and gravity. You see, the air functions as an oxidizer, and the outward pressure makes everything fly into the air and then collapse back to the ground. But this process is very different in space, and it looks even cooler. If a blast occurred in space, there would still be some fire despite the lack of air, because some kinds of fuels can act as oxidizers. But it wouldn't be the fire you're imagining now. This cosmic fire would look like an expanding ball of light. It would be a seemingly never-ending process due to microgravity and the lack of air resistance. Nearby spaceships would be in grave danger since the shrapnel would fly outward until something eventually stops it. All comets have beautiful long tails. Huh? It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. The inner and outer planets of the solar system are separated by the asteroid belt, a ring of asteroids and other debris and space objects orbiting around the Sun. While creating movies about space, filmmakers make sure to somehow use this region. Usually, they show the asteroid belt as an extremely crowded place with dense clouds of huge rocks you have to skillfully maneuver to get through to the other side. In reality, if you looked outside your spaceship while flying through this region of space, it would feel as if you're looking at the sky from Earth. All because of the ginormous distances in space. If you decided to cross the asteroid belt, there would be very little chance of a collision with a space object. Asteroids there are really spaced out and very far from one another. Black holes are giant, scary, cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star or any other object comes too close does a black hole spring into action. Even so, only those space bodies that cross a certain border get ripped apart. In fact, black holes aren't any different from any other celestial body since their pull is directly proportional to their mass. They can't swallow anything bigger than what their size allows. Even if our Sun was somehow replaced with a black hole as massive as itself, nothing would change for Earth or any other planet in the solar system. Gravitationally speaking, of course. Space battles in movies often involve using lasers. But if you were to see such a fight from up close, you would probably be disappointed. The thing is, it would be like nothing in movies. A laser beam is a concentrated burst of energy, and it could indeed be used for many purposes during a fight. But a real-life laser beam would be totally invisible in space since there wouldn't be any particles around to scatter the light and make the beam bright red or green or any other color. A human would be torn into pieces if they got into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk wouldn't be as dramatic as it's often pictured in movies. A person would just lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection. But that's if this person breathed out as much air as possible. Otherwise, this oxygen would damage their lungs from the inside, making them rupture. After that, without the protection of the spacesuit, the pressure inside their body would drop. This would cause even more serious trouble. And even though this person definitely wouldn't burst, they wouldn't want to stay outside for too long. People often believe that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon orbits Earth and the Sun doesn't float away out of our home Milky Way galaxy. Astronauts on the ISS do experience the effects of gravity, but that's not full-fledged. It's microgravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in freefall. The spacecraft, people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they are very different things. A light year must mean time, right? Not really. Light years actually measure distance. NASA's definition of a light year goes like this. The total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 186,000 miles per second, a light year equals almost 6 trillion miles. It may seem as if the sun is always on fire, At least that's what it looks like in pictures and in movies. But in reality, our star is a giant ball of gas. Nuclear reactions happening in its core at all times make the sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the sun does emit blinding light and incredible heat, but it's not actually on fire, because no oxygen is involved in the process. The speed of light is believed to be the ultimate barrier for people when it comes to space travel, and it's often thought to be impassable. There are many theories about what it might be like to reach that speed, but none of the equations account for going above it. And still, we know that at least one thing in the universe is faster than the speed of light: the rate of its expansion. Yep, the universe is expanding faster than the speed of light, baffling astronomers and casual sky watchers alike. Or at least we can say so in terms of the speed of different objects, like faraway galaxies relative to each other. At the moment, it's not something scientists understand well. The rate of the expansion of the universe is proportional to how far something is, too. The farther it is from us, the faster it's moving away. But even though we don't get the mechanics of it yet, we've got our proof, even though it's theoretical so far, that some particles might be able to travel faster than the speed of light. Some scientists think there could be more things out there in space that could challenge this speed barrier. All we need to do is find them.
So, you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So, if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort, rather significant to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than our Sun. Their event horizon is wide, and gravity doesn't change as quickly. So the force you'll feel at your heels and at the top of your head will be about the same, and you can go all the way to the heart of the black hole. This myth is busted. The next myth claims we can save the Earth from a giant asteroid with a big bam. The familiar plot is that a spaceship lands on the surface of an asteroid. A team of astronauts quickly drills a hole in it, leaves a present there, and flies away. Then, bam! As a result, the asteroid may break into several pieces and continue on its way to Earth. Well, big chunks of the asteroid fall to our surface, causing a lot of damage. So, our mission is failed. Well, to save Earth, we need a really big bam. Not only outside the asteroid, but right above its surface. When the boom happens, the force of the blast pushes the asteroid slightly downward. Even a slight change in trajectory would be enough to make the asteroid fly past the Earth in the future. Done! Oh, and if you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yeah, we often hear the sound of spaceships and battle in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you. The sound wave begins to push the first air molecule next to the clap, then the third, fourth, and so on until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. One more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid cloud. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the way to the moon, so there really aren't that many of them there. To understand the size of the emptiness in space, look at the collision of two galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. Another myth is that there's zero gravity in our orbit. Imagine you're in a huge box 10 miles up in the air. Now we let go of the box and it starts to fall. You're falling simultaneously with the box at the same speed. And now it's as if you feel zero gravity. Well, the same thing happens in orbit. The International Space Station is 250 miles above the Earth, and it's falling continuously, though not on the surface of the planet, but around it in its orbit. Its speed at this point is about 4.7 miles per second. It could cross the United States from the west coast to the east coast in just 8 minutes. So the astronauts there are experiencing the same thing. They're just falling with the ISS at that speed. Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So, whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. The astronauts didn't grab them when they left the moon. They left a lot of stuff there too. They even ripped out the armrests of the seats of the lunar module to reduce its weight. Now, the total weight of human trash on the moon is about 187 tons, including several lunar rovers, spacecraft debris, rocket stages, and lunar probes. That's like 3 Boeing 737s. The next myth is about summer. The hot season comes because the Earth approaches the closest distance to the Sun in a year. The Sun warms our planet more, and we all have to go to the beach. Well, not true. Let's draw an axis through our planet. It's slightly tilted on one side, and winter comes when our planet's axis is tilted away from the Sun. But over time, the axis tilts toward the hot star. Then its rays shine at such an angle that it gets warmer. It's true, though, that the Earth happens to be at different distances from the Sun. This is because our orbit is not a perfect circle, but slightly flattened, an ellipse. Normally, we think of the distance to our star as about 93 million miles, but that distance may be longer or shorter than 3 million miles, depending on which point in our orbit we pass. Another myth about the Sun is that it's yellow. Well, let's send you into space for this one. You look out the window and it's white. The Sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our Sun. But young and very hot stars are bright blue. The Sun is about in the middle of the spectrum. You've also heard about how if you take your spacesuit off in outer space, you'll blow up like a balloon. Well, our bodies are designed to function at atmospheric pressure, like outside. But space is a vacuum. Imagine a huge metal barrel, and we sucked all the air out from there. Add to that a temperature of minus 455 degrees Fahrenheit, and you have space. If you could get into those conditions, all the air pockets in our body, like our lungs, would start to expand. So you really could blow up like a balloon if it weren't for our elastic tissues. They stretch and bend, so you keep your body size. You'll have enough oxygen in your body to last about 20 seconds. Then your brain will begin to starve and soon you'll pass out. So you won't blow up, And you won't even freeze because you'll be in a vacuum. It doesn't conduct heat. For example, water conducts heat very well, and you feel cold from it instantly. But you feel better in the air of the same temperature. If you're in the vacuum of space, the super low temperature won't be a problem for you. Much worse is solar radiation. On Earth, we have a shield against radiation in the form of the atmosphere. It blocks the harmful rays. In outer space, you would be defenseless. Another myth is related to cell phones. People think that when you dial your friend's number, your phone sends a signal into space. There are a bunch of satellites out there that will pick up your signal and reflect it like a mirror right into your friend's home. No, not true. However, there are satellite phones in the world that work that way. But when you make a cell phone call, your signal is transmitted through a system of cell towers from one to another until it gets to your friend's phone. So, dark matter is a mysterious substance that makes up about 85% of the total matter in the universe. Yet, we can't see it or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the law of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going on for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future circular collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor. Wink, wink. It's a crazy massive region in space, about 10 million billion times the mass of our Sun, with a super powerful gravitational pull. Scientists think it might be a super cluster of galaxies, but they're not sure. The problem is, we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 370 miles per hour. Now, just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled toward this region, even though, since the universe is expanding, they should be moving away from each other. What's even weirder is that this great attractor might itself be moving towards something even bigger, the Shapley supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called Oumuamua. This was the first known visitor from another star system. The thing was quite small, from about 330 feet to about 0.6 miles long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed by the Sun, it unexpectedly sped up and then left our solar system just like that. Tons of theories started sparking up. It was too weird looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about Oumuamua ever since. But after a while, it turned out it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But Oumuamua caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years. Hey, stay tuned. Now, as for extraterrestrial creatures, where is everyone? There's this thing called the rare Earth hypothesis that suggest that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that with trillions of planets out there, there will be no planet like ours anywhere. But then, a geologist, Peter Ward, argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all of its astrophysical and geological conditions, should line up perfectly for complex life to develop. So just think about it. Being in the right zone of the galaxy, on a good distance around a stable star, a rocky planet with water and the right temperature, emergence of molecules, monkeys deciding to walk, and so on. This would explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter. Dark matter? And even if they do exist, we could be incredibly far away from each other. That would make communication or contact with other intelligent species very unlikely. Now, there's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe, although he assumed it's not because our planet was the result of tons of unique conditions, but because there must be some sort of filter that reduces the chance of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it or somehow ahead in the future, which means we might go extinct like many other species before us. Well, maybe in the next stages, such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up, potential catastrophes, resource exhaustion, or other challenges. Now, there's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. You see, in space you often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system, which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size. But the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kind of like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step. Activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed. So when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the Moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Sweep Mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the Moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the Moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the Moon is getting smaller, mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the Moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. We found a water cloud in space around a black hole. It's a gigantic water reservoir that's located about 12 billion light-years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic supermassive black hole. This quasar is about 20 billion times larger than the Sun and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that the water isn't young at all and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the Sun. Think about that. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Marsquakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to higher resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the Moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future. At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turn to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over. Slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood. So, once they explode, stars aren't supposed to come back to life. But some of the stars somehow have survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 4365. It's a partially burnt white dwarf. Now, a white dwarf is a star that has burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. One of those zombie stars used to be a white dwarf, or just left over from an explosion. It gobbled up too much from another star and, surprisingly, managed to explode once again. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1,000,000 years over there because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. In outer space, you'd be strong enough to weld two pieces of metal together with your own hands. Okay, it has nothing to do with your strength. You could just press them together with no effort, and that's it. Oxygen in our atmosphere makes a thin layer on the surface of the metal. It's like a barrier, which is why such a trick is impossible on Earth, but perfectly logical in outer space. If you ever go to space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news? The skin is elastic enough to hold you together, which means you wouldn't explode. Yeah, small comfort, huh? If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around your eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, there's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space. If the fire breaks out in a rocket, you can simply turn off the ventilation system and voila! It can get more complicated if there's intense smoke, sparking, and material melting in conditions of reduced gravity. Regular foam fire extinguishers we use on Earth are useless here because they release foam randomly. Researchers are developing a fire extinguisher that will put out fires by using sound waves. The bigger the sound intensity, the bigger the flame they can put out. But the astronauts might end up deaf if the frequency is too high. A black hole is not like some starving monster that wanders around and has gravity so strong nothing can really escape it. When something comes close to the point of no return, which we also call the event horizon, it disappears. No way back. But quantum physics claims nothing can really destroy data, so it's a true paradox. Stephen Hawking was the one with the idea of how black holes don't really have event horizons. Maybe they have apparent horizons. Those trap things for some time only. After that, the trapped energy will somehow get away, but in a different form. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. It happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it in another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like 4 billion suns, but luckily it's far away from us. There are more than 23,000 pieces of so-called space junk bigger than a softball floating above our planet at speeds up to 17,500 miles per hour. Woo! And there are 500,000 pieces in general, some of them the size of a marble. Space waste is generally debris made up of natural particles called meteoroids and artificial particles, like things we make on the Earth. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world, from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space, but they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. There's a lot of it. It may even make 25% of the universe. Dark energy makes the rest of the 70% of the universe. Scientists don't know much about it, but they think dark energy could be behind the increasing expansion of the entire universe, while dark matter slows it down. Dark matter doesn't interact with us in any way that we know of, nor does it interact with itself. If it did, we might be able to find dark matter galaxies, dark matter planets, or such objects. Now, astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bit bored and wanted to check out how things were going in the direction of the cold spot. That's an anomaly in the cosmic microwave background map, or in short, CMB. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. But instead of CMB, they realized there's a giant area way colder than they'd expected. The team started tracking radio signals, but there were no radio sources in that whole volume. That means there are no galaxies or clusters, and since it's so cold, there's no dark matter either, or regular matter, so it really doesn't matter. The giant void is empty, and researchers think it could consist of dark energy. Light can still pass through it. It's not the only void in space, but it's the biggest one we've found. The area around a star is habitable when it's not too cold or too hot for liquid water to exist on the planet surrounding it. Let's say our planet was where Pluto is. It's too far from the Sun, which means our ocean and big parts of its atmosphere would freeze. But if the Earth was in Mercury's place, we'd be too close to the Sun, and the water on our planet would evaporate. Such habitable area is called the Goldilocks zone. So you can see where planets are located and assume if they have a chance for life on their surface. But Europa, one of Jupiter's moons, definitely breaks the rule. It's outside of the Goldilocks zone, but still kept warm. Not from the Sun directly, but Jupiter and its moons that actually pump energy into Europa. Europa changes its shape as it circles around Jupiter. It's similar to tides rising and falling on our planet. Water on the Earth changes its shape as a response to the tidal forces of our moon. When the same happens with a solid object, the object is stressed. That's how you pump energy into that object. It's like you're playing racquetball. You hit the ball around a couple of times before you start playing, like you're warming it up. You kind of distort the ball every time you smack it. The surface of Europa is frozen, but it has cracks in the ice. You can see ridges in the ice where there's a crack. Then those flying chunks shift and refreeze. You'd see a similar thing if you could fly over the Arctic Ocean in the wintertime. There are ice sheets constantly breaking and refreezing. So Europa can't completely freeze. Scientists think there could be an ocean of liquid water under the icy surface. Europa is not the only moon where this is happening. Another of Jupiter's moons, Io, is also warm because of such tidal forces. Io also has volcanoes erupting from within all the time. So it's not only that the Sun warms the space bodies and pumps them with energy. Many experts agree the universe might come to its end about 3 to 22 billion years from now. It's expanding all the time, which means it formed from a compact state. If it has a beginning, it's probably going to have an end as well. Yeah, I won't be around for that. One of the popular theories says the growth will slow down, and gravity will become the powerful force that will make the universe shrink. That will lead to complete chaos. Galaxies, stars, planets, space bodies, they will all move, collide, and, destroy one another. It's like the reverse Big Bang. Huge chaos, but this time, everything collapses. Well, on that cheery note, always stay on the bright side of life. Ruh-roh, there might be another universe, like a dark mirror image of ours, where time flows in reverse. This flipped-over world might also be the source of dark matter, the invisible substance that's all over our universe. There might also be many more universes out there, in which an exact copy of you woke up this morning, but it chose a white t-shirt instead of a red one, sending it on a completely different life path. But let's start with this elusive dark matter. It makes up most of the universe's mass, yet we're not sure what exactly it does or where it comes from. That's because it doesn't act like regular matter. We can't see it or feel it. We just know it's there because of how it seems to bend gravity. Even though regular matter and dark matter are very different, they seem to exist in a balance. Some scientists think this must be connected somehow. A new theory suggests that for every way regular matter moves, there's a mirror version of it in the world of dark matter, like a bridge connecting the two worlds. There's also a strange coincidence in regular matter where a neutron and a proton have almost the same weight. This allows them to stick together and make atoms stable, making everything that we can see with our eyes exist. If protons were a bit heavier, there would be no balance and atoms wouldn't form. In the dark mirror universe, maybe things happen differently. Maybe in there, the equivalent of a proton doesn't bind to other particles, leaving behind lonely neutrons, which could be the source of dark matter. This theory also suggests that dark matter might have its own chemistry, like dark atoms and a dark periodic table. For the longest time, scientists believed there was just one type of dark matter. Although these particles are similar in some ways, like being almost invisible, they may vary in their sizes, speeds, and how they affect regular matter. If this idea is right, it means there could have been interactions between our universe and the dark mirror universe in the past. Studying how elements formed in the early universe might give us clues about this. The idea of a flipped world has sparked curiosity and even some confusion in the scientific community in recent years. Astronomers use a theory called the Lambda CDM model to explain the composition and behavior of our universe. According to it, most of the universe is made of two things: dark energy and dark matter. Dark energy is like the pushing force that makes the universe expand faster. Dark matter is this invisible thread that pulls things together with its gravity, acting like a universal glue. Regular objects, like stars, planets, and comets, only make up a small part of the mix. The model also tells us about the Big Bang, and how everything started from a hot, crowded beginning, and how the universe has been growing and changing ever since. While this model seems to be correct in many ways, it doesn't explain all cosmic phenomena. If you were to draw this model on a piece of paper, it would look like a series of flat pancakes stacked on top of one another. Each one of the pancakes represents a rendition of the universe at a certain point in time. Yesterday's universe would stand below that of today, but it would be a slightly smaller pancake. By the end, you'll see that the universe's history looks like this giant upside-down cone, with its minuscule tip being the Big Bang. Beyond this point, we can't see any further away in time with the tools we have, so we don't know what's beyond. More so, we're still not even sure what happened immediately after the Big Bang. But if we simply apply the math, the universe might go beyond this historical tipping point, which could mean it could go in reverse, creating a similar mirrored cone where time would flow backwards, in our perspective at least. This alternative idea not only challenges our understanding of cosmic origins, but also raises questions about fundamental principles in physics. All the excitement around a mirrored universe also came from ANITA, a scientific instrument stationed in Antarctica, and its discoveries. This device saw some weird high-energy particles seemingly bursting from beneath the Antarctic ice. The problem with these particles is that they didn't behave as the laws of physics dictate. Scientists think they have a type of cosmic rays. They travel from space through the Earth and back out again. But the particles we already know about shouldn't behave like that. That's because higher energy particles usually collide with something inside the Earth and don't come out the other side like these do. They seem to be doing things both forward and backward. For now, there's no concrete proof of a mirrored universe. These particles could simply be ones we haven't discovered before, and scientists need to study them closely to come up with a definitive answer as to why they're behaving like this. Kind of like 4-year-olds. But what if there isn't just one other universe, but many more? This multiverse concept comes from ideas like the inflation theory, which says that our world had this rapid expansion in its early stages. While inflation stopped in our neighborhood billions of years ago, it's likely that it continues in other regions of the multiverse, creating different universes with their own laws of physics and unique characteristics. Our universe is the only one that we know of that can support life. We have stable stars that can provide heat and warmth, for example, which is crucial for creatures to start moving around. We also have an abundance of elements like carbon and hydrogen, which we also need to exist. The multiverse hypothesis gives an explanation for why our universe exhibits such life-friendly conditions. It may explain that there are countless other universes out there, with varying conditions, making the existence of life in at least one of them less likely. One fascinating implication of the multiverse theory is the idea of doppelgangers, these exact copies of individuals existing in parallel universes. This notion suggests that within the vast expanse of the multiverse, there could be infinite scenarios where identical versions of ourselves are experiencing similar events at the same time. Before we begin our travels to different universes altogether, we might need to understand our own. There's this galaxy, for instance, far from us, that might have no dark matter at all. It's about 250 million light-years away and looks normal at first glance. But if we look closer, we can't seem to find any dark matter. If it turns out that there are more galaxies like this one, it could change our ideas about how galaxies are made. Dark matter is usually thought to be necessary for this process, acting like the glue that holds the whole thing together. It is true, however, that this particular galaxy is more faint and has fewer stars than usual. When it was first discovered in 2019, scientists thought it might not have dark matter because of how fast it was spinning. The speed at which a galaxy spins tells us how much stuff there is in it. By comparing this speed with what we can see, astronomers can figure out how much extra stuff, like dark matter, must be there. And in this unique galaxy, the math says there isn't any. Among all these theories, there's also one that says dark matter might not be real at all. This new study proposes that maybe we've been looking for something that doesn't even exist. They think that our understanding of gravity might not be good enough to explain why some galaxies behave oddly. So instead of dark matter causing these weird behaviors, they say it might just be that we don't fully understand how regular matter works. They base these findings on a theory called modified Newtonian dynamics. It suggests that gravity behaves differently at very large distances or very low speeds.